So today we're going to be looking at electrode potentials and how we use those to work out whether or not a reaction will take place, whether or not it's feasible. This is just going to be a revision lesson. I'm not going to go into too much detail about redox itself. So first of all, electrode potentials are measured by setting up a standard hydrogen electrode and pairing it with the particular element that you want to determine the electrode potential of. So in this case, if we were to place a voltmeter here, which isn't actually shown, we would find that silver has an electrode potential of plus 0.8 volts. Now we're able to measure that for any element we like. So two electrode potentials are shown here for silver and for bromine. So what would happen if we placed a piece of aluminium into a solution of bromine? Well, first of all, we have to compare the two electrode potential values that we've got. So aluminium has got a more negative electrode potential than the bromine. So we would expect the aluminium to be oxidized. So the one with the more negative electrode potential is the one that gets oxidized. So in this case, aluminium will be turned into aluminium 3+. This top reaction would go right to left. Now, because the bromine has got a more positive electrode potential, we would expect the bromine to be reduced. So the aluminium, because it's got a more negative electrode potential, is going to be oxidized, and the bromine, because it's got a more positive electrode potential, is going to be reduced. So if we were to mix the two together, we would end up with that equation at the bottom. And I've balanced that. So another example here, we've got zinc nickel, and the question asks us, would there be a reaction if zinc metal was mixed with a solution containing nickel 2+ ions? So we do exactly the same as we did before. We look at the two electrode potential values and we find that zinc has got a more negative electrode potential. So we would expect zinc, which is the thing we're starting off with here, we would expect that to be oxidized, and we'd expect the nickel 2+, because it's got a more positive electrode potential, we would expect that to be reduced. And the equation that we get, this one's a bit more straightforward because the zinc is giving up 2 electrons and the nickel needs 2 electrons in order to be reduced. That's the resulting equation that we get. So just for completeness, we're going to have a look at the other scenario. If we started off, say, with zinc 2+, and we mix that with some nickel, would a reaction take place? So again, we look at our two electrode potentials, and we find that zinc, as we saw previously, has got a more negative one. So the more negative electrode potential will contain the one that has the oxidation step. Now zinc, as we can see here, has already been oxidized. So because zinc has got a more negative electrode potential, it is unable to be reduced. So the zinc is unable to accept electrons because it's got a more negative electrode potential. So we'd expect no reaction to take place if we mixed zinc 2+ with nickel, because zinc has got a more negative electrode potential. And the other way around is also true, because nickel has got a more positive electrode potential, it is unable to be oxidized.